Hello and welcome to my channel, The Magic of Math, where together we will strive to master math concepts. I hope you'll show your support by clicking on the bell and subscribing to receive future video notifications. Today, we're going to be watching a video on algebraic properties, and we will be learning about how to use and identify algebraic properties. So let's begin by identifying our objectives today. Students will be able to identify and use the following algebraic properties: the commutative property of addition and multiplication, associative property of addition and multiplication, the identity property, the inverse property of addition and multiplication, and the distributive property. Our essential question today, the question I want you thinking about as we proceed through the lesson today, is why are algebraic properties of real numbers important? More than that, why are they important to you? The reason I feel they're important is for you to be able to solidly understand why you make specific math moves, the different steps that we do to solve equations or order of operations, and they're all based and founded on these algebraic properties. And they will help you build confidence that you have arrived at the correct solution because you'll be more confident in the steps that you are taking to solve problems. So let's first talk about the commutative property. Okay, so the commutative property states that the order in which you multiply does not change the solution of an equation or an expression. So it refers to order. So let's look at the commutative property of addition. It states that a value A added to a value B is equal to the value B added to the value A. So it's saying the order in which you add two values does not matter and will not change the solution or the value of the expression. So here's an example. If we let A equal 2 and B equals 7, we know that 2 plus 7 is 9. 7 plus 2 is also 9. So you can see the order in which you add these two numbers doesn't matter due to the commutative property. Commutative property also works for multiplication. For multiplication, it states that a value A multiplied by a value B is equivalent to the value B multiplied by A. So let's use numerical values for A and B. So I'm going to let A be equal to 3 and B be equal to 4. The commutative property again refers to order. So the order of 3 times 4 will result the same product as 4 times 3. So if you reverse the order when you multiply, you're going to get the same product. 3 times 4 is 12. 4 times 3 is 12. So it checks. Special note, subtraction and division are not commutative. Order matters when you subtract and divide. So let's take a minute and look at this special note about subtraction and division. I'd like to prove to you with numbers why these do not work. So we're going to look at it again and understand that it does not work. There is no such thing as the commutative property of subtraction. I'm showing you this just simply so that you can understand and visually see it does not exist. So if it existed, it would state that A subtract B would be equivalent to B subtract A. But we know this is not true. Remember, if you can disprove something once with one set of numbers, then it's false. So if I let A be 5 and B be 3, 5 subtract 3 is 2, and then we have to say 3 subtract 5 because we're saying that order would not matter. 3 subtract 5, 3 add negative 5 is negative 2. 2 is not equivalent to negative 2 and therefore disproves the commutative property of subtraction. So again, commutative property is not true for subtraction. Order matters when you subtract. When we divide, same thing. There is no commutative property because order matters. So if it were true, it would state that value A divided by B is equivalent to the value B divided by A. given value of 10 and 2, 10 divided by 2 is 5, 2 divided by 10 is 0.2 or 2/10. It's not equivalent. Therefore, we can state that the commutative property only applies to addition and multiplication. Moving on to the associative property. The associative property states that how values are grouped does not change the solution of an expression. So associative property refers to grouping. In math, groups are usually shown with parentheses. So first, let's review the addition associative property. So here's our groups. Parentheses show our groups. So we have three values, a value A plus B plus C, and we're going to group B plus C and then add it to A. On the other side of the equal sign, we're first going to group A plus B and then add it to C. So let's plug in 2 for A, 7 for B, and 3 for C. So again, we're grouping. 7 plus 3 is 10. And here we're grouping the first two. 2 plus 7 is 9. Now we can just add the two values. 2 plus 10 is 12. 9 plus 3 is 12. So it checks. Now let's look at multiplication. So now we're going to have repeated multiplication. A times B times C on both sides. The first side of the equal sign, on the left, we're going to group B and C. And on the right, we're going to group A and B. So let's use some numbers. So first, we're going to group the second two numbers, 4 times 2, which means we're going to multiply these first and then multiply by 3. Over here, we're going to group the first two values first and multiply by 2. So 4 times 2 is 8, and second step will multiply by 3. Here, 3 times 4 is 12. Second step will multiply by 2. So 3 times 8 is 24. 12 times 2 is 24. Another note. Subtraction and division are not associative. Order matters when you subtract and divide. So let's look at this and we'll quickly disprove the associative property. So to prove that it only exists for addition and multiplication, it does not exist for subtraction. It would state that if you group the second two numbers and subtract them from A, that it would be equivalent to the first two values and then subtract C. We go and plug in values for these A, B, and C. So first you would group 6 subtract 5, which is 1. 4 subtract 6 is -2. And we can see that 4 minus 1 is 3, and -2 minus 5 is -7. Not true. We'll find the same to be true of division. We can prove that this is not true, putting in values. So I'm going to divide the second two in my group of parentheses. 4 divided by 2 is 2. 12 divided by 4 is 3. And 12 divided by 2 is 6. 3 divided by 2 is 1.5. Not equivalent. So again, we can conclude that the associative property, as the commutative property, only applies to addition and multiplication. So let's use what we know on understanding order of operations. Order matters when simplifying expressions using order of operations. We have just proven that order matters using commutative and associative properties. So now let's introduce you, or review if you already have heard of it before, PEMDAS. It's an acronym. P stands for first, simplify inside the parentheses. E, simplify the exponents. M and D go together, multiply and divide in order from left to right. And then A and S, add and subtract in order from left to right. So this is what's really important. If the students read this and they say, okay, do P, do E, do M, then do D. M and D go together, and A and S go together. So we multiply and divide in order. So it might go multiply, multiply, divide, multiply. So I'll show you some of these. We'll model this. But M and D are together. And then you do all the addition and subtraction together. So let's talk about the identity property. The identity property states that there is a value that when applied to any number, the number stays the same. So identity, no matter what you do to it, it will stay that identical number. There are 4 different identities. We have identity of addition, which states that any value A, when you add 0, you get A. And you could try this with all different numbers. Let's try 5. 5 plus 0 is equal to 5. Any value added to 0 will equal that value. So when you have the identity property of addition, when you add 0 to any number, the number stays the same. Let's look at a subtraction property of identity. So it states that when you subtract 0 from any value, the value stays the same. 3 subtract 0 is 3. So when you subtract 0 from any value, you're going to get that value. So again, the identity property of subtraction states that when you subtract 0 from any number, the number stays the same. Let's look at multiplication. It would state it would be 1. Any value A multiplied by 1 will equal that value A. We can model this with 7. 7 times 1 equals 7. Any value multiplied by 1 will equal 7. So because it's the identity property, it states that when you multiply any number by 1, the number stays the same. And last, the division. Identity property of division. A value A divided by 1 will equal that value A. 2 divided by 1 equals 2. So once again, the identity property of a division states that when you divide any number by 1, the number stays the same. So remembering addition and subtraction involve 0 for their identity property, and multiplication and division use 1. Now let's talk about the inverse property. The inverse property states, and it applies only to addition and multiplication, the inverse property of addition states that for any real number, there is a value, which is called the additive inverse or the opposite, that when added results in 0. So an additive inverse or an opposite is when you add one number to another number will always equal 0. So think of it kind of undoing something. The inverse property of multiplication states that for any real number, there's a value, which we refer to as the multiplicative inverse, which is a big mouthful, also known as the reciprocal. And when you multiply, it results in 1. So the inverse property of addition, the two values will have a sum of 0. The inverse property of multiplication, they will have a product of 1. So let's look at the inverse property of addition. We're going to have a value A. We're going to add the opposite value. Opposite would be negative. 5 and negative 5 equals 0. Think about money. If you have $5 and you spend $5, you have $0. So how you can talk about spending: credits and debits. What you have in your wallet, what you take out of your wallet, and it gives you 0. Multiplication is a little bit trickier. The reciprocal is a flip. You put the value in the denominator with a numerator of 1. So A multiplied by 1 over A is equal to 2. Is equal to 1, sorry. I was thinking about using 2. Let's use 3. 3 multiplied by 1/3 is equal to 1. Think of it this way. 1/3 of 3 is 1. If you have $3, you can divide it into 3 groups, and each group will have 1. The only real number the inverse property does not apply to is 0. 0 is neither positive nor negative, and therefore does not have an additive inverse or an opposite. and the multiplicative inverse or reciprocal is undefined since you cannot divide by 0. So the inverse property of addition and of multiplication will work for any number except 0. All right, let's talk about using this inverse property and why it's important that you know it. First, we're going to use the inverse property of addition. So we have a simple equation here, x plus 13 equals 22. If we add the additive inverse, or the opposite, to both sides of the equation, and the opposite of 13 is negative 13. If you think of this as positive 13, $13 in your wallet, take away, subtract the $13. When I subtract, these are opposites or a 0 pair, and I'm left with just x, 22, and negative 13 or 9. Now let's use the inverse property of multiplication. We're going to multiply both sides of the equation by the multiplicative inverse or the reciprocal. The reciprocal of 1 over 4 is to flip it, so it becomes 4 over 1. I'm going to multiply both, and I always will get 1. 1/4 of 4 is 1. If I have $4 and I make 4 groups, each group has $1 in it. So then I have to do the same to the other side. 5 times 4 is 20. So the solution would be x is equal to 20. Last but not least, let's talk about the distributive property. The distributive property means to share. When you distribute something, you're sharing. Think about having friends over for a birthday party. If you are going to distribute cupcakes, you means you're going to share cupcakes to all your friends. So whatever you do, you want to give the same to all your friends. You don't want to give one friend 0 cupcakes. If you're giving everybody a cupcake, all your friends would expect a cupcake. You'd be a rude host if you didn't. So it states to share this value. So we have A, and then we have a group, B plus C. And there's an invisible multiplication sign. My little cursor's right here. There's an invisible multiplication sign here. So it means take A and multiply it to B, and take A and multiply it to C, and then you add them together. So AB is A times B, add A times C. So A times B, A times C, and then you have to add. So let me show you this. We have 3 times x, 3 times 4. 3 times x is 3x. Remember, there's an invisible multiplication sign there. And 3 times 4 is 12. If the mathematical expression does not have a variable, you may use the distributive property or order of operations. So I could state 2 times 4 right here, and then add 2 times 7. 2 times 4 is 8. 2 times 7 is 14, and 8 plus 14 is 22. So this is the distributive property. Order of operations would say, add what's in your parentheses first, which 4 plus 7 is 11, and then multiply. 2 times 11 is 22. So 2 different methods, 2 different properties, and both work. So your turn. I want you to determine what property is being used to justify this statement. 9 plus 4 is equivalent to 4 plus 9. If you need to, when we go through these problems, go ahead and pause, write down what you think the property is, and come back and hit play when you're ready. Welcome back. The answer is the commutative property of addition, where order does not matter when you are adding 2 numbers. Next question. Determine what property is being used to justify this statement. Go ahead and pause, come back when you're ready. Welcome back. The solution is the distributive property. 8 times x, subtract 8 times 1. Your turn. Determine the property, come back and hit play when you're ready. Welcome back. So here we have the inverse property of multiplication. 3/4 and 4/3 are reciprocals. You can see that they change numerator and denominator. We flip it. 3/4 and 4/3 are multiplicative inverses or reciprocals and have a product of 1. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. Go ahead and pause. Come back when you're ready. Welcome back. Our answer is the associative property of multiplication. When you have repeated multiplication, which we have 5 times 6 times 3, 5 times 6 times 3, that you can group two pairs, a pair of numbers, and then multiply by the third, and which two you multiply first does not matter. All right, your turn. Please pause. Come back when you're ready. Welcome back. This is the identity property of addition. When you add 0 to a value, it's the identity. It'll be equivalent to -2/3. Your turn. Please pause and come back when you're done. Welcome back. The solution is the inverse property of addition. These are opposite values. If I have $7 and spend $7, I will have $0. What is the additive inverse of 5? Pause, return when you're ready. Welcome back. The additive inverse of 5, remember the additive inverse is another word for opposite, is -5. The opposite of having $5 is owing somebody $5. Another one, what is the multiplicative inverse of -1/7? Please pause, come back when you're ready. Welcome back. So again, this is another word for the reciprocal. Reciprocals have the same sign. So because this is negative, my reciprocal or multiplicative inverse is also negative. I flip it and I get 7. Some of you might be thinking, well, where's the 1? 7 over 1 is still 7. -7 over 1, still -7. Here's a 3-part question. I would like you to simplify this mathematical expression, first using the distributive property, second using order of operations, and then tell me, did you get the same answer? And are part A and part B both valid methods? Please pause and come back when you're ready. Welcome back. Let's work through this. So part A, using the distributive property, I'm going to share the 7 to everything inside. Remember, the 3, the -10, and the 4 are all friends at the party, and they're all going to get 7 pieces of candy. So 7 times 3 plus 7 times -10 plus 7 times 4. 7 times 3 is 21. 7 times -10 is -70. And 7 times 4 is 28. Now, I'm going to group these. I'm going to add 21 and 28 together first because they're positive values. 49. And now I've got to add -70, which gives me -21. Using order of operations, the first thing I want to do is add everything in the parentheses. So I'm going to add my 2 positive values first. 3 plus 4 is 7. And then I need to add the -10. 7 plus -10 is -3. Multiply, and I get -21. I got the same value. So I did indeed get the same answer, and yes, both part A and part B are valid methods. Distributive property and order of operations are both valid strategies. Your turn. I would like you to solve this, and my hint would be to use PEMDAS, order of operations. Please pause, come back when you're ready. Welcome back. Let's see how you did. So the first thing I want to do is identify P for parentheses. So I'm going to tell you that the answer was 47, and now I'm going to model it. There are no parentheses. E is 4 exponents, so I have 3 cubed, or 3 to the 3rd, which means 3 times 3 times 3. So 3 times 3 times 3 is 27. The next thing I want to do is identify multiplication and division. So I have 12 divided by 4 and 27 times 2. I have to do them in order. For first, 12 divided by 4 is 3. Add 27 times 2 is 54, and then I'll subtract 10. So now I'm to the A and the S in PEMDAS, and I'm going to add and subtract in order from left to right. 3 plus 54 is 57. 57 subtract 10 is 47. Your turn. Go ahead and try this one. Come back and hit play when you're ready. Welcome back. Let's see how you did. So we're going to start by first evaluating the numerator. So when I look at that, I'll give you your answer first. So the answer to the whole thing is 1/2. It simplifies to 1/2. So let's look at this numerator. There are no parentheses. There are no exponents. So I'm going to look for multiplication and division. Here I have 4 divided by 2. So now this gives me 10 subtract 2. 10 subtract 2 is 8. So the numerator is simplified. Now I'm going to go to the denominator. So there are no parentheses. There are no exponents. So I'm looking for multiplication and division. So my multiply is 7 times 2. So 7 times 2 is 14. Now I'm ready to add. 14 plus 2 is 16. And 8/16 simplifies to 1/2. Your turn. Now I'm going to ask you to think about grouping. I would like you to add parentheses to this expression so that when you use order of operations, it simplifies to 1. Go ahead and pause. Good luck. Come back when you're ready. Welcome back. Let's see how you did. So here's the solution. If you add a set of parentheses around 2 subtract 9 and another set around 3 plus 4, this will simplify to 1. So we're going to do what's inside the parentheses first. 2 subtract 9 is -7. 3 plus 4 is 7. Now we're going to divide. We're looking for multiplication and division. There's multiply right here. 5 times -7 is -35. Divide by 7. -35 divided by 7 is -5. 6 plus -5 is 1. And there you have it. Those are our algebraic properties. You'll be applying these as you move through your math classes. Refer back to these anytime you are unsure of what to do. So there we have it, the magic of math. Thanks for joining me today. I hope you have a great day. Don't forget to subscribe and leave a comment.